Welcome to the Project Radium demo. This is a tech preview and represents no commitment to deliver the features shown. Project Radium virtualizes devices on remote machines for clients needing acceleration services, primarily for machine learning applications. Project Radium uses a general approach to system and memory events that is not specific to any device, vendor, or API. In this demo, Radium clients will find remote devices on Radium servers. We will migrate processes between clients and servers, and we will run TensorFlow applications using remote NVIDIA and AMD devices for acceleration. We'll be using machines on 3 separate hosts named Alpha, Mike, and Galaxy. Alpha has no GPUs. We have shells for them arranged as shown here. Alpha will be the client where we run our applications. Machine Mike has 2 NVIDIA V100 GPUs. Machine Galaxy has 1 AMD MI100 GPU. In the terminal for Mike, we run the NVIDIA SMI command on a 2-second loop to monitor the GPU status. And on Galaxy, we run ROCm SMI for the same reason. You can see the monitoring output here in the 2 terminals on the right. For the first part of the demo, we run Radium's client list command on Alpha to see the GPUs available on our 2 servers. Mike's V100s are listed, along with the Galaxy's MI100. Now we will migrate a thread while it is executing. We start on the client side, printing hello with the socket's host name. Then we migrate to the server and repeat the print and host name. Lastly, we return to the client and print once more. In our case, we purposely do not virtualize the getHostName call, so it will always execute where the thread is currently running. The host names printed out will be different as we migrate from one side to the other. We have not virtualized devices yet, but we have shown we can migrate execution. Now, instead of print commands, we could do something more complicated, such as importing TensorFlow. So, let's use TensorFlow to list the devices available to us. If we run that on our client, it will list only the CPU, but if we run it under Radium, it will list the CPU and a requested GPU. Here we see only the client's CPU. While under Radium, we see the CPU and a GPU. Or we can request and see 2 GPUs. Now, let's run a machine learning app, a small TensorFlow MNIS ConvNet example. We'll run this using an NVIDIA V100 GPU and monitor its activity on machine Mike. We observe the GPU memory being allocated. As results are printed out on the client, we see computation occurs on the remote GPU by the statistics in the GPU utilization column where we are monitoring activity. For convenience, we are compressing the elapsed time. A very important aspect of Project Radium is its ability to work with multiple vendors. So now we move to the AMD MI100. We'll use TensorFlow to list the device and then to run a different small MNIST application. We run the list device command again, but request AMD devices from Radium. Again, the GPU is listed. Now we run the application. In the monitoring output of Galaxy, we see memory allocation. Then we see the application progress on Alpha and computation in the GPU column of Galaxy. As you can see, with Project Radium, we are able to execute TensorFlow workloads not only on remote NVIDIA GPUs, but also on remote AMD GPUs. Thank you for watching.